Today we're going to learn about graphing linear inequalities in two variables. And we'll start by learning about half-planes. A line, any line, will divide the plane into two half-planes. A vertical line will divide it into left and right half-planes. So here is a vertical line over, just as you would expect, everything to the left of the vertical line will be included in the left half plane, and everything to the right will be in the right half plane. If we draw a non-vertical line, here's a non-vertical line. We think of it as dividing the plane into upper and lower half planes. So here is our upper half plane. And here is our lower half plane. Let's graph a linear inequality. We're going to start by looking at inequalities that are related to the line y equals 2x plus 1. So first we graph the line. We look at its slope, usually called m, which is 2. Sometimes we write it as 2 over 1 to remind us that it will be the vertical change over the horizontal change. The y-intercept is 1. Let's put a scale on this. We're going to use 1 square for 1 unit in both the horizontal and vertical directions. So I start by putting my y-intercept on my graph, and I realize slope, I'm going to go vertically by 2, horizontally by 1. Realize that the slope being positive means that it will go uphill as we move from left to right. So here are some points on my line that I get by counting the slope. In other words, 1 to 2, rather 2 to 1. Sometimes that's called rise over run, if that helps you remember it. So we draw our line. And so this is the line y equals 2x plus 1. If y is exactly equal to 2x plus 1, it puts us right on that line. The related inequalities are going to be y greater than or equal to 2x plus 1, y less than or equal to 2x plus 1, y greater than 2x plus 1, y less than 2x plus 1. In order to graph any of these, the first thing we do is we graph the line, as we've already done. Okay, so here for y greater than or equal to 2x plus 1, I'm going to go ahead and draw my line. I won't go through the details this time, but this is the same line that we graphed a moment ago. Okay, so if my y is exactly equal to 2x plus 1, it's on the line. So now my y has got to be greater than or equal to 2x plus 1. So my y has to be bigger, which will put me above the line. So in this area up here. Okay, so our area that we want is going to be the upper half plane, which is going to look like this. Okay, so everything above will be shaded. Sorry, the technology is going a little wacko on me here. Everything above the line is shaded. Now let's do y less than or equal to 2x plus 1. So once again, we draw our line, same way we drew it before. Okay, there's my line. Seems to be staying in the right place now. Since my y is less than or equal to 2x plus 1, that means we want to shade everything that falls below that line. So everything down here. Now let's look at y greater than 2x plus 1. So this is going to be the same as the first one that we did, except y is not allowed to be equal to 2x plus 1. That means my point cannot be exactly on the line. It'll be everything above the line, but not on the line. The way we indicate this is by graphing the line, except we're going to graph it with a dashed line, like this. This indicates that the boundary is not included. And so since we want the y's bigger than 2x plus 1, we will once again shade everything above, like that. Y less than 2x plus 1. Here, again, we will shade it. We will draw the line, but we will draw a dashed line to indicate that the boundary is not included. So now we get this. Everything below the line is shaded. So everything down there. This is the idea on graphing linear inequalities. Let's go through the general process. Now, sometimes our line will not be written in slope-intercept form, like that first line that we did. And of course, you are always welcome to change it into that form, but really there's an easier way, which I'll show you. First, we're going to go ahead and graph the line. Usually the easiest way to do this is to use the x and the y intercepts. Then we're going to choose a test point that is not on the line, and we're going to substitute those coordinates into the inequality and notice whether it is true or false. If it's true, then we need to shade the half plane that contains that test point. If it's false, we need that test point to not be shaded, so we will shade the other half plane.